Question 79. By evaluating integration I square R dt, show that when a capacitor is charged by connecting it to a battery through a resistor, the energy dissipated as heat equals the energy stored in the capacitor. So we know that current is given by I equal to I0 e to the power minus t upon RC. This is case of charging. Now we have to evaluate I square R dt. So it will become I0 square R times e to the power minus 2t upon RC dt. We integrate it. I0 square R times this will give RC upon minus 2 e to the power minus 2t upon RC. So from here, we can write it minus C by 2 I0 square R square e to the power minus 2t upon RC. If you remember, V equal to V0 e to the power minus t upon RC. So here we can write this in terms of voltage. So it will become minus C by 2 times V square. So that is energy dissipated as heat. We can also evaluate energy stored, and we know that energy stored in a capacitor is equal to half CV square. So modulus value of the two are equal. Now, question number 78. A parallel plate capacitor is filled with a dielectric material having resistivity rho and dielectric constant K. The capacitor is charged and disconnected from charging source. The capacitor is slowly discharged through the dielectric. Show that the time constant of the discharge is independent of all geometrical parameters like the plate area or separation between the plates. Find this time constant. So we know capacitance of a parallel plate capacitor with the filled dielectric between the two plates is epsilon naught A times K divided by D, where D is the separation between the two plates. Now, if we find the resistance of this dielectric, so that will be R equal to rho L upon A. Here, L will be this separation, because we have to find out the resistance of dielectric. So we can write it as rho D upon A. Now, charge Q is given by Q0 e to the power minus T upon RC. This is case of discharge. Now, we put the value of R and C here. Q0, Q equal to Q0 e to the power minus T upon RC. So R is rho D divided by A into C is epsilon naught A K divided by D. So D will cancel out, A will cancel out, and we will get Q0 e to the power minus T divided by epsilon naught rho times K. So here, this is time constant. So time constant, this time constant is independent of separation between the plates and plate area A, and we can write it as tau is equal to epsilon naught rho times K. This is required answer. Now let's move to next question. Question number 79. Here we have to find out the charge on each of the capacitor 0.2 millisecond after the switch S is closed in the figure. Here this is switch S, 2.5 ohm resistor, 2 microfarad capacitor, 2 microfarad capacitor. This is 6 volt battery. So if we find equivalent capacitance, so C equivalent will be 2 plus 2. That is 4 microfarad. Now, since it is case of charging, because when switch is closed, so charge will be equal to Q0 1 minus e to the power minus t upon RC. Q0, Q equal to CV from here. C is 4 microfarad into voltage applied. Voltage is 6. So this will be 24 micro coulomb. Here we write 24 into 10 to the power minus 6, 1 minus e to the power minus t. T is 20, sorry, 0.20 into 0.2 into 10 to the power minus 3 divided by RC. R is 25 and C is 4 into 10 to the power minus 6. So if we simplify it, we will get 24 into 10 to the power minus 6 into 1 minus e to the power minus 2. Now, if we put the value of e as 2.72 and we evaluate it, so our answer will be 18.4 into 10 to the power minus 6 coulomb. Now, this charge will be equally divided. So here charge will be Q by 2, here charge will be Q by 2. That is charge on each capacitor will be 18.4 divided by 2, that is 9.2 into 10 to the power minus 6 coulomb. That is our answer. Thank you for watching.